Hello everyone, so in this video we'll be seeing how to analyze a unreplicated full factorial design. So in my previous video I talked about how to analyze the replicated full factorial design with center points, but in this case you can see that there are three factors with which are two level continuous variables, and there are only 8 runs because there is no replication or center point. So let's see how to analyze this. So to start the analysis, you just click the green triangle next to the model, and here you can see that thickness has been added as the y variable, and you can see the main effects and the two-way interactions here. Let us also add the three-way interaction like before, and click cross. Now you can see main effects, two-way and three-way interactions, and now click run. So here you can see by default jump does not show the summary of it and the Anova table, which are important for us. But yeah, so now one thing you can see here is that if you look at the effect summary, you can see that you don't see any values. And also you can see that the Anova table, there is no p-value or f ratio. So in such situations, what you do is first you go to the fx test table and look at the individual sum of squares value. So here, higher the sum of squares value, that means more it is contributing towards the model. So in this case, oh, and by the way, if you look at the analysis of variance, another thing that you can see here, the error is 0 because this is an unreplicated experiment. We don't have multiple runs for each condition. That is why this is the error is 0 over here. But yes, as I mentioned before, so here you find the value that has the least the amount of sum of squares. So here you can see viscosity into time has the lowest contribution towards the sum of squares. So this can be removed from the model. So here you find viscosity and time, and then you can remove that. Say continue. So here now once you remove the variable, you can see that now the fx summary table has been uh, it is changed, and now you can see p-values for everything. However, all of them are not significant at the moment. I'll come back to that in a bit. Under the Anova table, you can see that there is p-value, f ratio as well, and even the prediction profiler has changed. If you go to parameter estimates, now you can see p-values for the individual, and so we can see in the fx summary as well. So now again from the table we removed all the non-significant terms, right, starting with the value that has the highest p-value. So now you can see that the speed, viscosity, time, the three-way interaction is not significant, so we can remove that. Speed and time are not significant, so that can be removed. Speed and viscosity is also not significant, so that can be removed. So now you can see that the model has only the three main effects, and all of them have significant p-values. And you can see under the Anova table the p-value is become significant, and under the parameter estimates you can see that the p-values are once again significant. FX tests show the same thing. You can also check the VIF factor just to see if there is any collinearity. There is none. And so now let's go to the prediction profiler, and like before you are interested in spinning the target value of 50. So I'm here changing this to match target and say okay, this will change. So now you go to the red triangle next to the prediction profiler, optimize in desirability, and then say maximize desirability. So now here you can see that in order to achieve your desired thickness, the most optimal way to do that is by using a spin speed of 3904 rpm and having a viscosity or concentration of 2.75 and a spin time of 29.27. And other than that, you have various other options that are available from uh, the prediction profiler here, from the red triangle option here, and Yes, so if you have two-way interactions, you can also use uh, the interaction profiler, which it is not active now because there are no uh, the two-way interactions in this particular model. So yes, and also you can save some of the predicted formulas as well.